typical grain loading machine deposits the concentrates in boxcars. This mechanical loader enables uniform distribution of the concentrates in the car. At Herculaneum, Missouri, 35 miles from the mines and mills, is located the smelter, which has been in daily operation since 1893. Here, the high-grade concentrates from the mills receive their final processing. Every day, long trains of boxcars containing the concentrates arrive at the smelter. From each car, samples are taken for assay to establish its moisture content and the exact percentage of lead. The plant laboratory also maintains close control of smelting operations. Scoop grain unloaders are used to unload the ore into mixing bins, where fluxes will be added. All the fine materials around the plant go into the sintering mixture. Additional fluxes are limestone, silica sand, iron oxide, and granulated slag. The collected fluxes and concentrates are delivered by conveyor to a huge pan where they're thoroughly mixed. Pallets carry the mix under gas-fired burners. During this slow process, ignition takes place from above. Suction fans create the necessary draft in a downward direction through the pallets of sinter mix. The method of igniting the mix may be likened to a man lighting his pipe and drawing air through to keep the tobacco burning. The smoke and fumes pass downward through the pipe bowl. Similarly, the gas burners ignite the sulfur in the mix. The suction of the fans draws smoke and fumes down through the sinter bed. The fumes are collected and treated for the recovery of lead content. Burning for 10 to 15 minutes reduces the sulfur content and leaves the pellet in the form of a porous cake or clinker, which is cooled by a water spray. From the pellet, the steaming hot sinter cake passes over a grizzly and is dumped into a car for delivery to the crushing plant. Through the openings of the grizzly bars, the finer material passes to a hopper and thence to a conveyor, which carries it to storage bins where it's kept in readiness for the final roasting, after which it may be smelted. Underneath the blast furnace bins, an electrically operated Larry car collects the various fluxes required for the charge. The charge for smelting in the blast furnace consists of sinter, coke, and slag. When the charge has been collected, the Larry car runs over a pit and drops the charge into a blast furnace charge car below. After the transfer is completed, the charge car is elevated to the charging floor of the blast furnace building. The blast furnaces require periodic relining. They're 20 feet high, with a hearth 50 inches wide and approximately 16 feet long. The hopper of the charge car, electrically operated by remote control, is rotated and dumped into the top of a furnace. The blast furnaces are operated continuously in 3 8-hour shifts, 7 days a week. Furnaces are provided with inlets which admit the oxygen for burning the coke. Air is forced by large blowers through a bustle pipe to the inlets and then upward through the charge. Slag is tapped from the furnace intermittently. The heavy lead, metallics, and matte, a combination of other metals with sulfur, settle on the bottom of the hearth, while the lighter waste product or slag flows over the top and into the slag pot. At the side of the forehearth, the matte is tapped from the bottom and flows into a matte pot. And this is then transported to the granulator. Matte is a combination of copper, nickel, iron, and lead sulfide. In molten form, it's poured into a high-pressure water stream. The force of the water, the sudden change in temperature, solidifies the matte into small particles, which are sold for their metal values. Each furnace produces 200 tons of crude lead every 24 hours. This, after processing in the refinery, yields 150 tons of refined lead suitable for market. From a furnace, the lead is taken to a drossing wheel, where part of the dross is removed. Dross, containing such impurities as copper and nickel, along with a high percentage of lead, is skimmed off with a large ladle. It's poured into molds to form rough pigs, which will again be run through the blast furnace to recover their lead content. After this preliminary skimming of the dross, the lead is taken to the refinery for the further elimination of its impurities. The lead pot is hoisted by an electrically controlled crane, which is operated from the floor, and the metal is poured into the rough drossing kettle. A perforated dross basket with a capacity of 3.5 tons is immersed in the kettle. Skimming off the dross, the basket is hoisted by the crane and suspended above the kettle while the metallic lead drains back. A centrifugal pump is inserted under the small remaining quantity of the dross and serves to pump the metallic lead to an adjoining kettle. Different types of lead are made according to the uses for which the metal is intended. Here, the remaining dross is removed, and the lead is allowed to cool to 625 degrees Fahrenheit. This is called chemical lead. Other types of lead are made where it's necessary to remove the silver to improve the purity of the lead. Zinc is added to the metallic lead in the refining process for the removal of silver. The zinc alloys with the silver, then floats to the top and is skimmed off. This beautiful seal of the great state of Missouri is made entirely of silver recovered from refining Missouri lead. Designed by the distinguished American sculptor Paul Manship, it has been donated to the battleship Missouri. The zinc also removes whatever copper and nickel are left in the lead. After removal of the silver, the lead is pumped into a gas-fired furnace for removal of the 0.6% of zinc which has been left in the course of the desilvering process. Pure lead from the dezinking furnace is pumped into a holding kettle for partial cooling. Thence it's piped to the casting wheel where it's poured into 100-pound pigs. The metal flows through a pipe supported by a harness over the operator's shoulders. This operation calls for the skill of a three-armed man, as the workman pours and simultaneously skims the metal with paddles in both hands. Rotation of the casting wheel is electrically controlled by the operator. The filled molds pass through a continuous spray of cold water applied at top and bottom to cool the lead. An automatic marking device stamps the identification or production number on each pig. 5 at a time, the 100-pound pigs are plucked from the casting wheel by an ingenious device called a pick, which operates by compressed air. With each load, the pick is swung around, and the pigs are stacked in piles 7 high. The lead pigs are cast with protruding ears to facilitate handling and shipment. An electrically operated lead loading buggy picks up the 3,500-pound stack of pigs, lifting them by the ears, and transports them to the weighing scales. After which, the metal is transported by electrically operated loaders and delivered to freight cars on the refinery siding. With each car loaded to its capacity of about 50 tons, the metal lead is sent out to the many various industries to be converted into useful articles for mankind. This pig of lead, weighing 100 pounds, has been obtained from the smelting of about 138 pounds of concentrates, which by milling have been produced from approximately 3,300 pounds of ore taken from the mines. In the milling process, about 3,100 pounds of almost lead-free limestone was discarded as waste, locally called chat. The industry consuming the largest tonnage of American lead is the automotive industry. Almost every car uses lead in storage batteries, solder and bearing metals, and even in brake linings. In addition, lead is used in gasoline for better performance. Lead storage batteries are also widely used in airplanes, submarines, industrial lift trucks, power plants, farm and car lighting, and mine locomotives.